Okay. Serious talk here to start this video. Basically, I've got like no likes or subscribes from any of you in this class. And I mean, I'm producing high quality stuff here. And for you to not take the time to hit the like button and the subscribe button and the notification button, honestly, you deserve the bad luck for 55 years. You deserve it. I don't even feel bad about it now. I don't even feel bad. You're going to have bad luck 55 years. Most of you, like, you're going to be 70 years old by the time your bad luck ends. And you know what? I'm happy. I didn't think I'd say that, but I'm happy. Whatever. That's how you guys want to be. Fine. Let's just do math then. No fun. No fun math now. Today we're going to do reciprocals. It's going to be boring, and no one's going to enjoy it. If you remember to do a reciprocal graph, you have to take the bottom of your old fraction and graph that thing. If you were to graph x minus 2x plus 2, it would look a little something like this. A little something like that. Then I can reciprocate that graph. And if I reciprocate that graph, it will give me this thing, which is exactly what I'm looking for. There's 3 steps to any problem, just like there's 3 steps to liking, subscribing, and getting notifications, whatever. There's 3 steps to this question. The first step is to draw your asymptotes. Asymptotes happen in 2 different places. The first place it happens is your NPVs. That's also the x-intercepts. So if you're graphically looking at it, you're looking for x-intercepts of that blue graph. If you're looking at the actual algebraic part of it, my NPVs were -2 and 2. So that means my vertical asymptote should be at -2 and 2. Like that. The second spot for an NPV, for an asymptote, is the x-axis. So it's always right here. In the future, that might change. Math 30-1, that changes. But in Math 20-1, it just always stays there. Cool, so that's your first step, right? Draw your asymptotes. The second step is to hit the subscribe button. Just do it. It's not hard. The second step to this question is to label your invariant points. Invariant points are things that don't change. That's what means invariant means, and it doesn't change. Hopefully, not like your attitude towards subscribing to my channel. So invariant points always happen in 2 spots. They happen at y equals 1. So on this blue graph, y equals 1 would be right here and right here. The second spot that it happens is at y equals -1, which in this case would be here and here. Awesome. The third step is to now reciprocate. And when you reciprocate, if it's a quadratic, which in this case it's clearly a quadratic, and you know it's a quadratic because I've taught you so well this semester, and still you won't appreciate my videos. Anyways, you know it's a quadratic, so the first thing you should reciprocate is your vertex. My vertex is down here at -4. If I was to reciprocate that, it's 1 over -4, which is -0.25. My dot is now up here. And again, if you look at this graph, my asymptotes have basically broken this graph into 3 parts. So there's this part of the line, the light green that I just did. Then there's this purple part of the line I'm going to draw. And then there's this black part up here. And you need to reciprocate those three sections separately. I like to imagine those asymptotes like fences, and it's broken my quadratic into three sections. Right? So I have the green, the purple, and the black. You need to reciprocate each one of those sections individually. So if I was to reciprocate the green section, I would put my pencil on the invariant point, go towards an asymptote, and then run alongside it. And the same thing in the other direction towards the other asymptote. If I look at this middle section down here, the purple section, to do this one, I put my pencil this time on my vertex, go either left or right towards an invariant point. So I'm going to go left towards an invariant point. I hit that invariant point, and then I go towards my asymptote, and I run along the side of it. I could also go the other direction, go through the asymptote, and go straight down like that. The third section would be up here, it'd be this black section. If I was to graph that thing, pencil on the invariant point, go towards one of the asymptotes, run along the side of it. And same thing in the other direction, like that. Awesome. That green graph is your rational expression or your reciprocal graph. That green graph is 1 over x minus 2, x plus 2. Cool. I think those ones look the best when you're done them. If you want to scroll down to this question, pause the video and see. Actually, don't pause it yet. I'm going to draw the bottom graph for you. And then pause the video and try your best. So this thing right here would look like this. I think. Yeah, it would look like that. Okay, pause the video, try your best to do this question, and maybe when you unpause, maybe I'll do the question with you, or maybe not, because maybe I'll just shut down my YouTube account, because what does it even matter anymore? Whatever. All right. Hopefully you pause the video and unpause the video. I am going to go over it, because it's my professional obligation, but I'm not happy about it. So the first step, hopefully you did this, was draw the asymptotes. They happen in two spots. They happen at my x-axis right there, or sorry, my x-intercepts of the blue graph, or the NPVs, depending how you want to look at it, and they happen at the x-axis. Second job was to label the invariant points. Invariant points happen at 1 and negative 1, so they should have happened right here at the vertex, coincidentally, and negative 1 is down here. Third job would be to reciprocate. You should always reciprocate the vertex first. You actually can't reciprocate this vertex because the vertex is an invariant point, right? It's not going to move. So that's going to cause us a little bit of a trouble in that top section, but we'll deal with that in a second. If you look over here in the bottom left section, if I want to reciprocate that, I put my pencil on my invariant point, I go towards an asymptote, and I draw an arrow. Same thing, other direction, like that. If I look at the right section, it would look like this. Invariant point towards asymptote, invariant point towards asymptote. This top section is a little trickier. If you're struggling with a section and you're not sure what the reciprocal would look like, pick some random points and reciprocate them. So if I took a point right here, that would be approximately, 0.5. 0.5 would reciprocate, 1 divided by 0.5 would reciprocate to be 2. And that point goes up like that. On the other side, I have another y equals 0.5, so it also would reciprocate up to 2. And then I can at least see a little bit of a trend. My graph is going to go from my invariant point towards the point I just graphed, and then along my asymptote. And same thing other direction. And I got that by looking at other points in that section and then reciprocating them. So in this case, I did 0.5. Oh no, it's gone. Cool. That green graph is your beautiful reciprocated graph, that green one. And you probably got 100% because you got the best math teacher in probably Canada. Not that you'd ever pay attention, to his greatness. And subscribe, like he wants one thing for Christmas, a subscription from everybody. Then I can start charging ads and make some money on this. You know what I mean? You know what I'm saying? All right, that's it. That's reciprocating graphs. You can unreciprocate things too. Okay, so we'll look at a couple examples of how you could unreciprocate a graph to get the original quadratic or the original linear equation. So if you look at these two, we're going to try to unreciprocate them. To unreciprocate them, we're just going to work backwards. So the first step is normally asymptote, right? So this time, I'm going to look where my asymptote is and realize that that means on the original graph, it must be my x-intercept. So when I see that asymptote there, what they're telling me is there was an x-intercept there at one point. So that means I'm going to put a dot right there. The second step is still invariant points. Invariant points happen at y equals 1 or negative 1. In this case, negative 1 is right there and right there. And I can tell this is a quadratic because look at the shape it's making. Once I have those 2 points, now I can just do my third step, which is draw it out. Reciprocate. This graph would have looked like this. You could always reciprocate as many points as you want on the graph, right? You could take more points and reciprocate them if that makes you feel better. But once you think you see the trend, you could just connect the dots and draw it like that. Cool. If we look at B, first thing I'm going to do is find my asymptotes and write those as the x-intercepts. You'll notice this thing has no asymptotes. That means there's no x-intercepts on my other graph. So when I convert this thing or reciprocate it, there's going to be no x-intercepts. Second step is do your your invariant points. I keep saying the wrong thing. No wonder you guys don't subscribe to me. I wouldn't subscribe either. Invariant points are at y equals 1. It's right there. There's only one invariant point. The third step is to reciprocate, and I can't reciprocate this thing right now. At least I can't draw it. The reason I can't draw it is because I only have 1 point. Only point I know is that yellow point. That's why they gave you 2 more random spots. They gave you these 2 random values for a reason, and that reason was so you could reciprocate their y values. So that point of 1 over 4 is going to reciprocate to be 4. That means this point is going to go all the way up to there. And same with the other one. It's going to go all the way up to 4. Because that's the reciprocal of 1 over 4. And now I do have points that I could connect the dots. I'm going to connect my quadratics to my invariant point to look like that. Cool. There's 2 more down here. I'm going to do pause them, come back, and then see how you do. So pause the video. Cool. I'm going to do them kind of quick so you can see if you got it right. So the first thing I do is I take the asymptote, which is this line right here, and I'm going to turn that into my x-intercept because that's how it got there. Then I'm going to do invariant points at y equals 1. Those invariant points are right there and there. Now that I kind of have an idea of the shape, I'm just going to connect the dots like that. That's my quadratic, the green line. If you look at B, I'm going to do the same thing. So first thing I'm going to do is I'm going to look at these asymptotes right here and realize that those were x-intercepts on the other graph. So I got 2 dots, 2 x-intercepts, one here, one here. Second thing I'm going to do is I'm going to label my invariant points. My invariant points are at -1, which is here and here, as well as +1, which is here and here. And if you see, like, there is a bit of a trend here. My graph's going to look something like this. But we don't really know how high it's going to go. So when you do your reciprocating, if you can see that there's a vertex, then you should reciprocate that vertex. So I can notice that this thing is going to create my vertex, which is also why they told you the y value of it was 1/2. So when you do that vertex, it's going to turn into +2 right there. And now I can play connect the dots. My graph looks like this. That was my original function. Awesome. The next questions we're not going to do. If you want to look at them, you can. You don't need to know them. They're kind of a little extra. Honestly, online learning stuff, and you guys have been crushing it. Thank you for tuning into these videos. Thank you for doing as much work as you guys have been doing. It's been fantastic. I don't think there's a group that deserves this break more than you guys. So thank you very much for all the effort you put in December. And I really hope that I see your smiling faces back in January. I feel like I'm going to give every one of you a hug because I'm going to be excited to see you. So take care of yourselves. Reach out. Come chat with me if you need chat. We got a quiz coming up tomorrow and a test the day after that. And then it's Christmas break, baby. You get the two very well-deserved weeks off for you guys. All right. Take care. See you soon.